Hi there. For this video, we'll be solving quadratic equations using the completing the square method. So in the last video, we had this example: u squared plus 6u minus 5 equals 0. And since we weren't able to factor this one out using our concept on factoring quadratic trinomials, we weren't able to answer or solve that equation. But for this one, we'll apply the completing the square method to solve this. So the first step is to move this term without a variable to the other side of the equation. So we'll have u squared plus 6u equals negative 5 will become 5. And from here, what we will do is we will add a term in both sides of the equation to make this out here a perfect square. How do we do that? Well, we recall our concept on perfect square trinomial. That when we have a squared plus 2ab plus b squared, this factors into a plus b squared. So technically, this is called completing the square, since we will complete the square out here. We'll complete this square by adding a certain term. To determine that term, let's observe this general case out here. So far, what we have is the first term and the second term. We know that this middle term is the second term since it contains the square root of the first term, which is u, and in this case a. So to get b squared, what we do in this middle term is, if we have 2ab, first we divide it by 2a. So cancel this one out, and to obtain b, we square it and obtain this. So just like that. So in our example, what we do is, we first divide 6u by 2 times the square root of the first term, which is u. This becomes 3. Square that one, we obtain 9, and that's what we add out here. So we'll have here plus 9. Then recall that when we add something on the left side of the equation, we must also add that one on the right side of the equation, since we're dealing with equality. So we add 9 here. And now, we know that this expression out here is a perfect square trinomial. So it just factors into square root of the first term u, copy this sign, plus square root of the last term is 3, and we have square out here. And on the right side, we have 5 plus 9 is 14. Then from here, this is the useful trick that is helpful in completing the square. What we do is we get the square root in both sides. So we know that on the left side, since we have a square out here, and we know that the index here is 2, by first law of radical, this simply just cancel out and we'll have u plus 3. And on the right side, square root of 14 cannot be simplified anymore, so we just keep it at square root of 14. Is this it? Well, don't forget to write the plus minus signs. Since this is an even radical, there is a principal and secondary root. So don't forget the plus minus sign. And from here, what can you observe? We have turned the quadratic equation into a linear equation, since the highest degree out here is just 1. So from here, we simply just move this to the right side to obtain u equals -3 plus minus square root of 40. And this one here is the answer. Note that this means that u is equal to -3 plus square root of 14, or u is equal to -3 minus square root of 40. Let's try another example. Let's have x squared minus 4x minus 21 equals 7. Again, the first step is to move this term without a variable to the right side of the equation. And so we obtain x squared minus 4x equals 7 plus 21. Now it's completing the square type. So we add something out here and something out here. Determining what we should add, focus on this middle term. So we have -4x, divide 2, and divide the square root of the first term, which is x. Then from here, what we do is simplify this. We obtain -2. Square -2, and we obtain 4. And so that's what we add out here. So we have 4 and 4. From here, we know that the left side of the equation is a perfect square trinomial. So this just simplifies into square root of the first term is x, copy the sign, minus square root of the last term is 2, don't forget the square out here, and this one is equal to 7 plus 21 is 28, plus 4 is 32. So now here we get the square root both sides. And so we'll have, on the left side, we'll have x minus 2. On the right side, note that in simplifying this, we have square root of 32 is equal to square root of 16 times square root of 2. Square root of 16 is equal to 4. And square root of 2, we can simplify that. So this one is the simplified form already. So we have here 4 square root of 2. And don't forget the plus minus sign out here. From here, since it's just a linear equation, we just move this 2 to the right side to obtain x equals 2 plus minus 4 square root of 2. And this one out here is the final answer. Let's have this third example. Let's have y squared minus 5y equals -7. So the setup is already good since we have already moved the term without a variable on the right side here. Oops. So we just give some space and perform completing the square. So again, to determine that, focus on this middle term. So we've got -5y, divide that by 2, and divide by the square root of the first term, which is y. This one simplifies into -5 over 2. Square this one, and we obtain 25 over 4. So we'll add 25 over 4 out here. From here, we know that this expression is a perfect square trinomial, so this just simplifies into square root of the first term is y, copy the sign, that is minus, and square root of the last term is 5 over 2. Don't forget the square. This one is equal to, let's solve this one. We know that this one, we can write it as -7 times 4 over 4 plus 25 over 4 this is equal to negative 28 over 4 plus 25 over 4. Simplifying, this is negative 3 over 4. So we have here negative 3 over 4. And now we get the square root both sides. So we'll have on the left side y minus 5 over 2. And on the right side we'll have, first simplify this. So note that this one is equal to square root of negative 3 over square root of 4. This is equal to square root of 3 times square root of negative 1 over square root of 4 is 2. And this one is equal to square root of 3i over 2. So we have I here since I represents the imaginary number, which is square root of negative 1. And so we have here square root of 3i over 2. And don't forget the plus minus sign. From here, we simply solve this linear equation. So we move this negative 5 over 2 to the right side to obtain y equals 5 over 2 plus minus square root of 3i over 2. Combining these fractions, we have 5 plus minus square root of 3i over 2. And that is the answer. Just note here that since we have an imaginary number out here, this isn't really a real root for this equation. And yeah, but it's still useful since we're able to factor out and get a complex root for this equation. But just note that our focus is the real root, so we won't really consider this, but for the sake of completing the square, we consider this as a root. Now, so far in our examples, the coefficient of our leading variable or the squared variable is 1. What if we have 2z squared minus 8z plus 5 equals 0? Again, the first step is to move this term to the right. So we obtain 2z squared minus 8z equals 5 to the other side will be negative 5. And from here, we have two options. Either we divide each term by 2 or this one. I prefer this one, so we'll do it this way. So we can write this one as 2 times z squared minus 4z equals negative 5. So what did we did here? Well, what I did is I factored out the coefficient or the number 2, the factor 2 out here to obtain this one inside. And we will apply the completing the square method in this one. So we'll have this and this. So to solve for this missing term, we have negative 4z, the middle term, divided by 2 and divide by the square root of the first term, which is z. This one simplifies into negative 2, square that one, and we obtain 4. So we add 4 out here and 4 out here. But don't forget that we have a multiplier of 2 out here. So what we add on the right side of the equation must be 2 times 4. So we'll have here 4 times 2. So don't forget that one, since that is the crucial step in dealing with completing the square method with a coefficient on the leading variable that is not 1. So on the left side, since we know that this is a perfect square trinomial, this one is simply 2 times z minus 2 squared equals, on the right side, note that 4 times 2 is equal to 8. So negative 5 plus 8 is simply 3. And then we divide 2 on both sides. So this one out here cancels out, and we have 7 minus 2 squared equals 3 over 2. We now get the square root for this 2. To obtain, on the left side we have z minus 2, and on the right side we have plus minus. Let's simplify square root of 3 over 2. Let's write it out here. Square root of 3 over 2 is equal to square root of 3 over square root of 2. Since we don't want a radical in the denominator, we multiply square root of 2 over square root of 2. And this one is equal to, on the numerator, square root of 3 times square root of 2 is square root of 6. And the denominator, square root of 2 times square root of 2 is simply 2. So we'll have here square root of 6 over 2. Then we move out this negative 2 to the right side to obtain our final answer of z equals 2 plus minus square root of 6 over 2. This one out here is the answer. So that is how we solve using completing the square with a coefficient of not 1. Now, as an exercise, let's have your exercise. You can work on these 2 examples out here. So first, let's have b squared plus 9 equals 5 times 2b plus 5. So basically, in this example, it will first require you to simplify some things before you can apply completing the square method. And for this next one, you can try out and solve 3a squared minus 6a minus 47 equals 0. Observe here that in this example, the coefficient of our leading term is 3, so it's not 1. So you'll apply the similar trick that we did in the last example. So that's it for this video. I hope you enjoyed this one, and feel free to comment down below your answers and solutions to these exercises. So that's it, and yeah, that's all for this video.